Yeah, still pretty loud. Thank you. All right, so we got four more equations we're going to solve that'll basically kind of polish up like what's expected for you in 5-4. So we've got this little mini equation here. D equals 9k times the third root of p. So let's say we want to solve for p. All right, now p is buried. He's a radicand. He's buried inside a cube root. So we have to cube him when he is isolated. So let's make sure that we get the 9 and the k out of the way first. And since all all of those are being multiplied, we're going to undo that through division. Okay, so that's called the inverse operation of multiplication is division. All right, so now I have d over 9k equals radical cube root of p. Normally when we say radical something, it means square root. So I have to make sure that I say that clearly and say cube root or the third root. All right, so d over 9k, don't care what it is. Doesn't matter in the formula. If I'm asked to solve for p, I want to be able to do it in any field that I'm in. So I want to get p by itself, so I would actually raise him to the third power. Okay, and that effectively undoes the cube root. So now it's p equals d over 9k, but the whole thing gets raised to the third power. Now I could raise them all to the third power if I wanted to. It's no big deal, or I can just leave it like this. In a calculator, I would, if I was assigned this and I want to plug in d and a k, it's actually easier for me to actually do it this way, figure out what that is, and then cube it in the very end, all right? But that is actually your final answer, all right? So moving on to example 6 here. Let's see, example 6 is going to look like, all right, we've got 7 equals negative 3 plus, this is going to get a little fancier here. This is the kind of stuff that will help you in calculus, actually. We did this a lot. All right, so I need the x by itself. I want to solve for x. And so I've got some things that are actually, I don't have any other variables. So this means I can actually find the variable for x. Like I'm not going to be left with an expression here. I'm going to have a number, all right? Now, sometimes these numbers don't work, and so we call those extraneous solutions, if you remember that from absolute values, absolute value equations. So what I have to do now is use the anti-order of operations to solve for x. And so this square has to be done last. He has to be isolated. So I have to undo this guy right here by actually adding a 3 to both sides. Okay, now that gives me 10. Now that I actually have the radical isolated, I can now undo that radical through inverse operations. Now I can square, but just don't forget to square both sides. Okay, now it is, again, a good habit to put this whole side in parentheses because you have to square everything that's over there. All right, and so that's going to be 100 equals 4 minus 32x. All right, so now we're basically back to pre-algebra. I'm going to subtract 4 first, then I will divide by negative 32, so that's 96 equals, all right, divide both sides by negative 32, and it looks like I get x equals a negative 3. All right, so first I have to go make sure that negative 3 works, because it might not. So let's look. What you got to look out for here is if I plug in a negative 3 here, am I going to get the square root of a negative number? Because that's a sure way to guarantee that you actually don't have a solution. Now, if I plugged in a negative 3 here, let's just verify this here. 4 minus times negative 3. Okay, that's going to be a negative 96. Then 4 minus a negative. That's a positive. So that's going to go to 100. So then that would be the square root of 100. That's 10. 10 plus negative 3 is actually 7. So that works. That checks out. Okay, so always look out for extraneous solutions in these. Atticus is playing Hello Neighbor, and it freaks him out. He is obsessed with the game. It's kind of sad. All right. Our next example. I'm not making fun of you, Atticus. I'm just, students that watch this video, they're going to hear you go, ow! And they want to know what's going on. And, All right, now when this happens, this is a really nice unique situation because you have radicals that are isolated on both sides. This is basically, it nulls it out. All right, and basically you can ignore the fact that they are radical, because if I square this side, I have to square this side, and then what I'm left with is nothing other than the expressions, the radicands that are in them. So I got -7 minus 2a equals a plus 5. So if you see radicals on both sides and there's nothing else happening, all right, then it's great. They are undone. But, and this is not actually going to be in your homework because it's more for a pre-calc class, but if I just did this one thing, if I put a +3 here, just on the other side, it's a hard problem. Like, it got real tough. So that's not going to happen in your homework. But if I just put a +3 here and this guy was not underneath the radical, then things got really, really messy. Okay. But again, if both sides are balanced like this, okay, you can just ignore the radicals. All right, so I'm going to go ahead and solve this. I'm going to move this guy over here, and I will move this guy over here. It's going to be a positive 3a, and then a will be -4. All right, so let's see if we get a negative sign here. Positive and positive. So it checks out. That's good. All right, if you want to try it out for yourself, you can see that if I plug in a -4, I am not going to get the square root of a negative number. We're safe. All right, last example. All right, I saved the best for last here. Here is x minus. This is basically for a algebra 2 class. This is as hard as it gets there. I don't have a radical, but you see I have the variable in two different locations. And so I've got two x's being raised to the first power. So what I've got to do is I have to put the x to the other side. All right. And the x, I mean, is this guy, because this one is inside the radical. I can't undo it just yet. He's got to be last. So I'm going to actually subtract x from both sides. That's -3 minus x. Now, what will then happen is that I have to divide by -1. Okay, and that's going to give me a positive x and a positive 3. Whoa. Okay, you guys want to get dressed? That's the timer, buddy. Get dressed. We got to go for a walk. Okay, so now I'm going to square it. Now you notice that here's the issue. The issue is that when I square this guy, I have to square the x plus 3, not just the x or not just a 3. I have to square x plus 3. Okay, so now I got 3 minus x undone. Okay, and then what I have to do is, since I'm squaring x plus 3, you guys should be very familiar with having to unfoil something. All right, that's basically x plus 3 times x plus 3. So if I were to FOIL that out, I'd get x squared plus 3x plus 9. All right, and since this now is a quadratic, you guys have done these before. Since this is a quadratic, I'm going to move everything over to the right-hand side and make it equal to 0. So this is -3. He'll attach to there. This guy will be a positive x, and he will attach to there. Okay, that should be a 6x. Okay, so yeah, 6x. So now that's 0. Now I get x squared plus 7x plus 6. Okay, so I use the x method. Factors of 6 that add up to 7, 6 and 1. X plus 6, x plus 1. Okay, so this means that x equals -6 or -1. We've done these so many times over the year that should be very quick. Okay, but let's go back to the original equation. Is there anything that's going to cause me a problem? -6. If I put a -6 in here, does it actually work? So I do have to verify this. Let me check -6. -6 in the x minus 3 minus -6. Does it equal -3? And 2 plus, let's see, -6 minus, that's going to be plus 9. So that's -6 minus 3. Is that equal negative 3? I'll verify my answers here. Negative 6. Okay, it doesn't look like that actually equals negative 9. Okay, so I'm going to verify that in just a second. Let's try the negative 1. Negative 1. Okay, that one's true. That actually works. Now I want to try that negative 6 one more time, because what I'm worried about is am I doing something wrong here? Because this guy definitely works. Negative 3 and negative 1 is definitely an answer. It's a solution. Now let me try negative 6 one more time. I'm actually going to do it right up to the original equation, because I'm getting a little worried here. Negative 6. Yeah, just a minute, buddy. I'm doing a math problem. Okay, now I'm putting negative 6 for the x. So negative 6 minus, this would actually be, okay, that would be positive 9, so I'd get a 3. So negative 6 minus 3 is actually negative 9. So this means that this guy, negative 6, is an extraneous solution. So, what's the matter, Atticus? Okay. You had to start over the game?